Try and do a little build video on this. Got 4 of these Suzuki Samurai clutch plates in. They fit the shaft on the leaf motor fairly good. I've knocked the center out of 2 of them to get a feel for what I can do with this. I also got one of these BMW drive shaft cushion couplers, cush drive, whatever you want to call it. It's from a M3, so or an older M3, I believe it is. It's on the drive shaft, so it's after the transmission, which means there's a decent amount of torque that goes through this, so this should survive. Probably be more torque than I'm possibly going to make it. The motor is hard to say. Once I get to the bigger controllers we're going to do some testing with. This will probably be machined down with a little coupler that slides over this little ridge here. So I'll make a cool little build video on it. So looking at these things right here, they actually seem, measuring with my caliper, they actually seem to measure on the big part, measuring somewhere around there, about 0.15 millimeters smaller than this old coupler measured, somewhere around there. And then the inner part of the splines, get that as best we can, 2.24, 20.24, sorry, and like 20.44, so you know, about 0.2 millimeters smaller on the smaller part and 0.15 millimeters smaller on the bigger part. So that means this actually fits the dyno, the leaf motor shaft a little tighter, just to get in here and kind of show it. There's still a bit of play. It still slides on there fairly good. But you can see it's not a super tight fit. Moves a bit, but it's definitely a lot tighter than that old shaft. And just grabbing this here, I'm gonna have enough splines that I can fit 2 of these, and they're gonna grab a lot better. So there'll be 2 of these on each motor welded together to that coupler, and they might shrink a bit once the weld's done. If I do the weld just right, I'll probably weld a circle around the coupler that holds this, and then I'll probably get a piece water jet and make a piece that catches this bolt, this bolt, this bolt from one side, and then other bolts on the other side. So 2 of these will go on each side of this rubber cushion, and I'll have to knock these ears off probably, and I'll machine this down a little bit so that these, because you can see there's a bit of a bevel there. It's a little tricky with how bright it is outside, but there's a bit of a bevel there, so the trick will be to grind where they go towards each other, grind them so they actually sit nice and tight, so that the spline is almost, you know, so there is no bevel. That way you're getting the maximum use out of the splines you possibly can. And I think that's how we'll do that. So I'm gonna put a file together. A friend of mine sent me a file for something that he used this coupler for, so I'm just gonna modify the inner diameter of his hole, I think, and then basically send it to the water jet shop and get 2 of them made up. Just working on this design here, doing some measurements and everything. The file that my friend sent me wasn't the same dimensions. First off, the bolt holes, he has 10 mil bolts. I have 12 mil bolts. The diameter, the radius from these bolt holes to the middle, his was smaller than mine. So with this program I use, this one's actually pretty easy. It's called Design Spark. You can actually just click a surface, and you can actually make it bigger or smaller by pulling it. I'll just escape out of that because I got a dimension I like. But there's a lot of neat stuff you can do, so you can move things around and all that. So the last thing I think I need to do is move these bolt holes out to the right circumference. So once I'm done that, this part will be done, and then I'll export a DXF file to the water jet machine shop in town that can water jet this for me, and then hopefully we'll get 2 of these made up, 1 for each side. What I've decided is I'll just machine this ridge off here a little bit in the center, just so these can slide in. This center diameter there is to go over this ridge right here. Sorry, I might not have got that in camera. The center diameter there is to go over this ridge right here. And so basically put these 2 sandwiched together, make sure they're machined so that there'll end up being 1/2 inch clearance between the 2 of them. And I'll cut all these outer ribs off here, and then basically just weld them into the 1/2 inch thick piece of steel, and that should be 1 for each side, and that'll bolt right into 3 holes on this right here, 3 holes on each side with that triangle type shape. Should work well. To show part of the features in this program, like I just showed how you can pull a surface, you know, you can we'll just do that quick here. You can pull a surface to make it bigger, smaller. You can do lots of stuff. There's also another option for move, which hopefully this works correctly, and I can move this out. Escape. Let's see here. I want to move that. I want to spin this axis here so we can move it around, but unfortunately I'm not getting what I want, so I need to escape out of that. Essentially this is what I got to do though. So if I click this one, the axis here is correct, so I can actually move it. What I need to do is move it 8.285 millimeters. So we'll do that, and then I'll type in 8.285. I've got only one hand here, so 8.285, and then click enter, and it moves it out just like I needed it to there. So now we can escape. That one's where it needs to be. Now I need to move these 2, but unfortunately my axis, my origin points in the right axis for one of these 3 holes, but I need to figure out how to move the other 2. So I'll figure that out and continue making this, and then I'm actually, these last 2 holes, all I gotta do is figure out how to move them out towards the edges, and then I'm done, ready to send this file in. Alright, so I figured this out. Basically what you have to do is you have to highlight this here, and what that's going to do is when you spin this, you'll be able to see it's actually highlighted that hole and actually the corner, which is no big deal. And then basically what you come and do is you go to the move option, you go to create patterns, you give that a second, you click this, and then what you need to do is you got to click here, and you want to spin this until it shows 3. Count 3 and you're done. Whoops, I didn't mean to do that. There we go. That should be it. Everything should be good now. So basically what I'll do is I'll save this, and I believe I've got everything I need. We can double check like the hole diameter here, 12 millimeter. Check this one, 12 millimeter. They're all the same, obviously, because they're a pattern. Check this one, it needs to be 53.85, which is good. So I think we're good there. All they need is a DXF file, and then they can cut this out. They're going to water jet this from a 1/2 inch piece of steel for me. I'm going to make 2 of them. Should be good. Forgot to bring my GoPro to do a time-lapse video. Basically, cut all the outer pieces off these little hubs from the clutches. What I'm doing right now is machining them by hand with just a flap disc to make sure the space between this surface and this surface is roughly 1/2 inch. It can be just a bit over for now, and once I get those plates back from the water jet from the machine shop from being water jet cut, then I'll final size those to make sure they fit in. Those parts are probably going to not touch when I'm done, but the goal was to machine that down enough so that 1/2 inch steel will fit in there, and I'll make sure they fit tight to 1/2 inch steel, and the 1/2 inch steel will keep these lined up. So what I'll do is I'll put these on each side of the 1/2 inch steel, slide it on the shaft of the motor, and tack weld it. And then basically I will probably do that at home because I have a flux core 110 wire feed at home. It's kind of junk really, but I'll tack weld it in 3 or 4 spots as best I can, and then I'll probably bring it here and use a gas shielded welder, a really good Miller MIG we have here. So just using the flap disc, and you can kind of see the way it reflects where you have high spots and low spots. And the other trick I've been doing is just taking a felt and squiggling on it a little bit like this, and then you basically just take and put it on some sort of fairly flat steel surface and slide around and spin around a bit. And what you're doing is you're putting marks to show you where the high spots are. So what you can do after that is you just grind on the high spots a little bit. And I'm getting them close. I'm leaving it a little fatter than 1/2 inch gap between these two surfaces for now. You can see I've kind of machined outside just by hand this little ridge down. I'll get it a little better before I'm done today, but hopefully those water jet parts get done today, and then they're going to be little triangles like you saw from the other part of the video to fit with this. So they should come together pretty quick. It's also worth mentioning that part of the reason I'm machining this surface here down is because I've picked 1/2 inch steel to go between this ridge and this ridge. So basically these will squish together, and that'll actually make this grab on as much of the splines as possible. This is actually probably the perfect length now that I machine it down. I'm going to take these home and test fit them. Basically, so by grinding this surface down here that was a little beveled edge, there's still a tiny bit of a bevel left there for the gear, for the splines. I took most of that down, which means I'm now getting full engagement as much as possible on those splines. This should help. Like I said, I think I said in the last video, it should be somewhere between 3 to 4x the torque rating that other coupler that I had was. So this should help a lot. These should end up, they're already a fair bit tighter on the splines. They're going to be twice as long on the splines. They're a better metal. They're a better material made for grabbing, for high torque applications. It is a Suzuki Samurai, so it's not like a crazy amount of torque, but nonetheless, these should work pretty good. Just about ready to put all this together. So you can see what I actually did was I machined this side down and end up going down to basically get rid of most of that bevel, which is fine because, like I said, I needed to make sure that we're grabbing all the splines we possibly can on the motor shaft. Once this is put together, I left one side just like it doesn't wiggle in there, but it's loose enough I can turn it. The other side, this side's actually pretty tight. I actually think I squished this one in with a vise a little bit, just a smidgen. So the plan will be to slide this on the motor shaft this way, slide this other one on the motor shaft, and then basically put a few tack welds just with the flux core welder here at home. And then I'll take them in and use a better gas shielded MIG welder and weld basically all the way around this circle ridge here. And that should actually, it'll shrink it a tiny bit when that happens, which will make these a touch tighter on the shaft, and it'll make a really good lock. Like, I won't have to worry about the welds whatsoever, but not bad. This is the design that I was working on yesterday and sent it off at about 3 p.m. and these guys already got 2 of these machined up, or water jet up for me. So inside there I actually had to you can see I just had to take a tiny bit out with a grinder, not much, and then just run a drill bit. Like, I actually should show a video of it, but I didn't have a 12 millimeter drill bit, and you'll know that a 1/2 inch drill bit's much bigger. So what I did is I actually just put the next size down, I don't remember what it was. Nonetheless, I put a drill bit in there and just spun this thing holding the drill bit with both hands, and then spun it around on the drill bit, and that deburred it just enough that I can slide a 12 mil bolt through there. I got some brand new 12 mil bolts for it, so it should work out pretty good. Unfortunately, I just ran out of TIG wire. That's too bad. It looks like it's working well. So, to be continued tomorrow. Got some new wire. Hey, buddy. Are you excited? Okay, should we put it in? Get the welder working? Stay back, buddy. Go over to your chair for a minute. Okay, look that way for a minute. So I brought these into the university to use a much better welder. We have a pretty good inverter multi-use that has dual gas. So it has C25 for MIG welding, and then it has pure argon for TIG welding, which is pretty awesome. It does AC/DC TIG, stick, and MIG welding, which is pretty incredible. This is what I'll probably get once I get a bigger shop, more shop space. You know, our next house, whatever, however I work that out over the next few years, we're looking for more shop space. So what I'm going to do is I'm going to weld these here. And I'll probably do a spot weld on each side with a good welder. That way, as I'm welding it, these other cheap, I want to call them cheap, but these other welds from the 120 volt flux core welder, they're prone to cracking because it's really not that great of a weld. Like, you can do some stuff that doesn't have much stress on it, it'll be okay, but you should use a gas shielded, better quality welder. Now I am actually running this on 110 as well, 120, 110 slang for, it's actually 120 volt. But the good part about this welder is it's an inverter, so it actually has enough power. I've done a lot of, like, I've done 1/4 inch aluminum with that on just a 20 amp 120 volt plug. It's incredible. It is dual voltage, so I can run it off a 240 plug, but the 240 plug here in the shop isn't set up yet, so I'll probably have to, honestly, probably make an adapter cord for it if I really need 240 in the future. Nonetheless, gonna get some stuff started here. Has all these settings. You just basically set it up however you think it's going to need to be. It tells you, make sure you're connected to the right stuff. I think that's the wire I'm using, and we'll probably turn the heat up. Go to one of the thicker metal settings. Let's do 8th. That'll probably be okay, and then probably set it here to try it to begin with. Yeah, nice. Now that I got both tacks on each side and I trust it, I'm going to do the whole circle. Whoops. trying to go over that flux core weld. Not super awesome. I think for the next one I'll flip the camera over. Should be alright. And then I think what I'll do is where's a good place to do this? No, they're nice and hot, so set it there. Typically you want to quench something in oil if you're trying to heat treat it a little bit. Now that it's warmed up pretty good, I'm just gonna spray some engine store on the splines. Now obviously it made some smoke, so we'll turn on some ventilation. And I'll flip that over and make sure to get the other side. The splines probably didn't get really that hot, so this honestly isn't probably doing much for heat treating to begin with, but it's worth a little bit here. We'll just let it cool there while we're working on the rest of the stuff. I'll go turn on another vent. So after everything, I realized in order to take full advantage of the splines, as much of the splines as possible, I need to space these out a bit because this one was a bit short, so there's actually splines sticking out on each end. So by spacing these out a bit, they actually spread onto each motor further. The other option would be to go in here and cut these brackets here that hold the motor and try to move them over, which I never really made a build video on it, but I have a lot of time in lining the motors up so they're straight to each other and everything. So I think rather than messing with that, I'm just simply going to space these out with 2 washers on each side. So basically it'll come together like this. And then what we want to do is stand it up, make sure everything's good, poke these through a bit. I'm just going to get that in a bit better. So now that I've got those poked in, you want to put a bit of Loctite. Make sure, I'm going to use some red Loctite on each set of threads, and then basically 1 lock washer as well. So get that on there. We'll get this one started, and then the other 2 will be a little easier. Yeah. There we go. Sorry, trying to hold the camera and the coupler at the same time is tricky. Now that I got that started, I can get it a little further, and then we'll do the other 2. Get some Loctite on these 2. Definitely want to, you don't need to worry about being cheap. They're big threads, so too much, there's almost no such thing as too much Loctite on something like that. You don't usually use too much, like a whole big gob of Loctite. Something like this, it's a coarse thread. It's a 12 millimeter thread, and basically it's, oh, I forgot the lock washer. I'm more concerned about it not coming apart than anything. It probably won't spend a ton of time at high RPM, but eventually the goal is to spin this thing up to 15,000 RPM. That's where I've been revving these leaf motors before, and I do intend on getting back there. One thing to take note of though is I'll keep a close eye on this, maybe put a GoPro down there and watch this at higher RPM, and if it looks like it's going to be that, or the research I'll do into it, if it looks like it's going to be an iffy item to have spinning that fast, what I'll do is I'll just get this middle plate water jetted as straight steel, and then I'll try and put them back together with just everything bolted straight together, just for a few high RPM tests. It won't be what I run most of my testing with. That'll be the final stage of testing, essentially. It's just proving field awakening right out to max RPM. I might do it under light load just so we can prove that it controls current nicely and everything. And you know, maybe what I'll do is I'll set up both throttles, one on regen, and then run one at part throttle for the regen side, and then the other side at like full throttle, get it up to max RPM, and then increase the regen load once it's at max RPM or something like that, something to that effect, so that it's a little easier to control. Because right now what we have is a issue with controlling speed control on the regen side, and it's a complicated thing, but essentially the regen side is trying to do an RPM sweep, and then I drive the drive side with the throttle, and the drive side tries to push it faster, and the regen side tries to hold it at whatever RPM it's programmed to. That does a fairly good run, but when I let off the throttle for the drive side, sometimes the PID loops react too quick, or there's something going on there where it actually tries to jump really fast on RPM and gives me an overcurrent fault. So I've been tuning that out with PID loops, but I think we have a new software to try soon that's going to hopefully solve that. Anyways, put this together quick. Whoops. Set this down, it'll be a little easier. Gonna edit that out, right? Okay. Not a good thing for doing that. Anyways, let's get this last one, and then I'll go over them with a ratchet to make sure or a wrench or something to make sure I'm happy with all 6 of them. But looks pretty good for now. I think I might have the camera upside down. I don't know if that flipped around. Maybe it does it on its own. Either way, it does look like it should be good. And that now, if you stand it up like this, it's now a decent amount taller, which should engage on more splines. And that was the goal of the whole thing. Perfect. Should be good. Alright, it looks good. Really, there's no free play. There might be like a smidgen, but it's actually, you can hear it there. It's kind of buffered by the, I put an O-ring on one side and a little piece, I don't know if you can see it, this to spin up in here. Little tiny piece of rubber hose with a little shim. Kind of hard to, my arm's stuck around the side of the, there we go. This is a little spacer on this side right here, and then there's an O-ring beside it, and then on this other side I got a little spacer with a tiny little chunk of rubber hose just to kind of hold it centered and take some of the free play up. There's not much slack in those spines, and it's grabbing by more than it used to, so I have a lot of confidence in it now. I think that's it.